Okay, so let's start today's class. What we have discussed in the previous class. I think in the previous class, we discussed the types of fuel cell. Okay, classification of fuel cell, alkaline fuel cell, and phosphoric acid cell, acid fuel cell. So in the previous class, we already classified the types of fuel of the various types, classification of fuel cell, alkaline fuel cell, phosphoric acid fuel cell. Okay. In the classification, we just discuss about the fuel composition, that means classification of fuel cell. So just you maybe share the screen, and then we will continue here. Okay, fine. Okay. So just first share the screen, and then we will continue class. Okay. So in the previous class, just discuss about their composition classification of fuel cell. What are the classification? Just so we just discussed in the previous class fuel and oxidant combination, electrolytes, temperature, application. Okay. So these are all discussed in the previous class. Classification, and under the fuel oxidant combination, just we already discussed. So in the gas, liquid, and solid. Yeah. Hydrogen under the gas, lower hydrocarbons, and in liquid, we just discuss alcohols and hydrogen, higher hydrocarbons, and metal hydrides, etc. Okay, so we already seen in the previous class. So just to maybe yeah. So in the electrolyte, we already discussed in the suppose that in the composition. So we already first one discussed, and in the electrolytes, we already discussed about their alkaline fuel cell. Okay. Phosphoric acid fuel cell and molten carbonate fuel cell, solid oxide fuel cell, proton exchange membranes fuel cell. So these are under the electrolytes. Okay. The most common classification by electrolytes, it will be an aqueous, non-aqueous, molten, and solid alkaline and acid. Okay. And in the temperature, we seen that the under the category of low temperature 25 to 100 degrees Celsius, and medium temperature 100 to 500 degrees Celsius, and high temperature, that is nothing but 500 to 1000 degrees Celsius. Okay. and very high temperature above that is known as the 100 1000 degrees Celsius to operate the fuel cell. So just today we are going to discuss about the what is the fuel cell and fuel cell principle and working of fuel. What is the difference between the fuel cell and battery? Okay, so these are we are going to discuss today. Okay, what is the fuel cell, what is the principle, and how they can work in fuel cell. Okay, and actually, what is the difference? Main difference you may find out between the fuel cell and battery. So, whatever all these conditions we try to elaborate today one by one in a systematic manner. Okay, so just try to see what are the what is the fuel cell and how they can work. Okay, so just try to elaborate into the class. Okay, so as we maybe find out that the fuel cell, we are talking about the cell which is a fuel cell. So fuel cell is nothing but electrochemical device, one type, or we can say that a device that converts the uh, chemical energy into electrical energy. Okay, you may find out various way to produce the electrical energy in previous semester also. Okay, how we can generate the electrical energy in the power plant directly by the uh, driving the alternator by the different prime mover. Okay, so here we convert the mechanical that means mechanical energy into the electrical energy with the help of alternator. Okay, and that direct producing electrical energy supply given to the load, and according to their requirement they are able to use in the far located area from the generating station to the remote area where the load mainly install, okay, or use. So where we see that in that the you are most familiar with the production of the electrical energy directly, and that energy you may be transfer. So we find out that energy may not be available in all the rural area. Okay, electricity is not maybe conventional electricity. Okay, so available. So in that particular area, maybe you find out this type of application, or in urban area where the electricity conventional electricity is available, but during the interruption time, okay, suppose that in 1 hour or 2 hour in your whole day, maybe we will not find the conventional energy. So a lot of people were maybe installed some battery instead of fuel cell because that fuel cell may not be reversible. So one times if you use, then it will be rechargeable. Okay, that means this cannot be rechargeable. Okay. So we will find out fuel in that area where is conventional electricity is not available, where we can use this type of fuel cell. Okay, and here you may find out if the conventional energy are available, but if you want to do some another type of backup, in that case you maybe use battery. Okay, when the power available in that period you may be charge, and at the interval time you may be use that battery in the power supply. Okay, but where if in some area you may find out conventional electricity is not available. Okay, so in that place you may find out some conventional fuel cell battery is used for the purpose of electrical energy supply. Okay, very small amount that may not be very frequently used. Okay, but at a sometimes you may find out this type of application very uh, uh, highlighted in the rural area. Okay, so what will be happen in the fuel cell is nothing but whatever the fuel energy in chemical form are stored, that energy you have to convert in electrical form. Okay, so this is the basic fundamental concept about the fuel cell. Okay, that means chemical energy stored, that energy you have to convert into the electrical energy, and you may be available to use according to your requirement and at a very critical time. Okay, so we can say that the fuel cell is a electrochemical device that converts chemical energy into electrical energy, and the fuel cell is similar to other electric cells in the respect that it consists of positive and negative electrodes. Okay, that means with electrolytes in between them. That means the fuel cell is similar to other electric cell. We find out that means other battery of the rechargeable battery. Okay, cell in the respect to that consists of one positive electrodes and another negative electrodes. And between the positive and negative electrodes, we find out electrolyte materials. Okay, electrolytes materials. Electrolytes material. So just you maybe find here that so you may find out the other battery we already discussed. That means one electrolyte consists and one positive electrolytes and one negative electrolytes. Okay, so that you may be consider, and in between the positive and negative electrodes you may find out the electrolytes place. Okay, so similar to that one other types of electric cell whatever we study in the previous classes also. And before that. Okay, uh, that means say in the rechargeable type of battery or some like a capacitor and something like that. Okay, so we whatever the other electric cell we discuss, you may find out the similar type of a structure. That means one positive and one negative electrodes. Okay, with electrolytes placed in between the positive and negative electrodes. Okay, so you may say that in the systematic or in block diagram, that is what where the chemical energy here is stored, so that we may be convert into the electrical energy and use according to our requirement. Is it not? So this is the main function of the fuel cell. Okay, this is nothing but the chemical device that converts the chemical energy into the electrical energy, and their structure is similar to the other type of electric cell. That means we required at least two electrodes. That means whatever we find in the other electric cell, that means one uh, positive electrodes and one negative electrodes, and in between them you will find out electrolytes. Okay, so similar to that electric cell, you may find the structure in the fuel cell also. Okay, so is it clear to all of you? Okay, so this is all about the fuel cell. Okay, and next we just that means yeah. So you will find out their systematic diagram of the positive and negative electrodes. So fuel in a suitable form is supplied to the negative electrode and oxygen. Okay, and often that means from air, oxygen is supplied from the air to the positive electrodes when the cell operates. Okay, the fuel is oxide, and the chemical reaction provides the energy is the converted into the electricity. Okay, so you will find out the structure of the fuel cell here, the flow of the oxygen and this positive and negative electrodes. Okay, and here you will find out the between the positive and negative electrodes, the electrolytes. Okay, this one yellow is so the electrolytes, and these two are the positive and negative electrodes. Okay, so you will find out the positive terminals and negative terminals. Okay, so current is start to flow from this direction to this direction, and this is the load connection where that is used, the load. Okay, so this one convert the chemical energy into the electrical energy, and between them the electrolytes you have placed here. So this one is your positive electrodes, red one, and this one is your blue, that means negative electrodes. Okay. So and through this one we already say that this is your electrolytes. So between them positive and negative, and this one is the oxygen drawn from the air. Okay, and this one is hydrogen from this path and make the chemical reaction. Plus the fuel is oxide in the presence of this oxygen and hydrogen. Okay, so with the water and just produce the electricity. Okay, these two. So we can say that the fuel is in nothing but in the suitable form is supplied to the negative electrodes, and oxygen, negative electrodes and oxygen, and from air to the positive electrode. This one is a positive electrode. Okay, and the fuel is oxide, and the chemical reaction take place. The fuel is oxide, and the chemical reaction provides the energy, and the positive provides the energy is the converted into the electricity. Okay, so this is the arrangement of the positive and negative electrodes between them. Electrolytes is present here. Okay. Yeah, so this is about the principle and working of a fuel cell. This is principle and working of fuel cell, how we can work this fuel cell. We just elaborate in this part. Okay, so fuel is a storage battery, but with a regular supply of fuel and oxidant. So there is no charging and discharging with fuel cell. In fuel cell, we cannot say that the one time is able to charge, and again when we do supply to the load, then during that period the discharging. Okay, so this is not possible here in the fuel cell. So whatever the storage energy in the chemical form that you use in one times only. Okay, and when the chemical energy is released one times, we are not able to charge again here. So you can say that the fuel cell is a storage battery, but with a regular supply of fuel and oxidant. What will be? Okay. So there is no charging and discharging with fuel cell. The main component of fuel cell, we already discussed that the one is your anode and one is your cathode. That means anode is your negative electrodes. Okay, you will find out here this three component, that means anode, cathode, and electrolytes. Okay, so this one is your cathode at oxidant or positive electrode. We will see that, and anode is your fuel electrodes or negative electrodes. Okay, and electrolytes we find out acidic or alkaline. We will find out here the positive electrode and negative electrodes. Okay, and in between them the electrolytes is present. Okay. So this is the fuel electrodes or negative electrodes, we can say that, and at the cathode, oxidant or positive electrodes. Okay. And in electrolytes, you will find out acidic or alkaline. So this is the three main component of the any fuel cell. You may find out that is anode and cathode, fuel electrodes, and oxidant, or maybe we say that the positive electrodes or electrolytes. Okay. So this is the systematic diagram, whatever we explained in the previous slide. That means positive electrodes uh, or oxidant, and the negative electrodes, that means fuel cell. So and this one is your load. Okay, so electron start to flow from this point to this point, and this is your cathode and this is your anode. Okay, so current will be flow to the opposite direction of the flow of electrons. So you will find out the path of the current, the path of the current, the path of the current from this cathode to this anode. Okay, and from this path we just supply air. Okay, the vessels where the cathode and anode, and in between them hydrogen ions, that means electrolytes, is present here. From this path hydrogen fuel we just supply, and the whatever the excess hydrogen is out from this path. Okay, and gases out, and water, whatever the relation between the oxygen and hydrogen. Okay, so water is passing through this path. Okay, so this is all about the systematic diagram of the fuel cell. Okay, external electrical pathway we also shown here, that is the flow of electrons from this anode to this cathode. Okay, and this is the electrolytes, so that means the hydrogen ions, H plus ions. Okay, so this arrangement you will find out in that path. Okay, so this is a complete structure of the electrolytes, hydrogen fuel from this path and air from this one. So this is all about the fuel cell, how we can represent with the connection of load also. So is all about this systematic diagram, and their cathode and anode connection and load also. We just try to show here. Okay. So I think you will be familiar with the cathode, anode, and this terminal here. Okay. So just this is the path for the gas out and water is to. Okay. So just we try to see the next. That means, yeah. We find here. So the other component are fuel supplier, or you will find out oxidant supplier and containers and the separator, etc. So these are the component we already shown in the diagram. So other components, main component is your anode, cathode, and electrolytes. Okay, and this is another component. We will be auxiliary components, that means our fuel supplier, that means hydrogen, and oxidant, that means air. Through the air we just supply the oxygen as oxygen container, supplier container, and the separator. So a fuel cell system consists of fuel cell power section and fuel processor, power conditioning section, etc. Okay. So a fuel cell system consists of fuel cell power section, fuel processor and power conditioning section, etc. So when two permeable nickel electrodes are immersed in a well-conducting electrolytes. Okay. So you will find out electrolytes. One is your H2SO4, and that means electrolyte solution. Sulfuric acid, and say that is H2SO4 is chemical name sulfuric acid. Okay. Acid, then the same is acidic fuel cell. Okay. If we use the sulfuric acid as an electrolyte in the fuel cell, okay, so this type of cell we can say that acidic fuel cell. Okay, if potassium hydroxide we used as electrolytes, if the electrolyte solution, that means KOH, then we can say that this type of fuel is alkaline fuel cell. You know, the electrolyte solution is potassium hydroxide, that means KOH, that means alkaline, and then this type of cell is known as alkaline fuel cell. So according to their electrolyte used in the fuel cell, we can just classify it either is the acidic fuel cell or alkaline fuel cell. Okay. So this is the electrolyte is main component of the fuel cell. According to that, we just classify it according to electrolyte, which is your acidic fuel cell and which is your alkaline fuel cell. Next, we try to discuss here. That means so we find out their chemical reaction equation at the anode and cathode. Okay. So negative electrodes is fed with hydrogen bubbled around it through the solution. Okay. So we find out according with the path of negative electrodes, the supply of hydrogen, okay, the bubble around it through the solution, and positive electrodes is fed with oxygen, and electrodes are connected together through an external circuit. Okay, so you will find out negative and positive electrode in the previous diagram. Okay, this one. Okay, so positive electrodes is supply here the air, and through the negative electrode that we anode, hydrogen is supplied, okay, and the external circuit load is connected here. So that is explained in that slide. Okay, so, so that is saying here that the negative electrode is the same things mentioned here. Okay, so negative electrodes is fed with hydrogen and bubble around it through the solution, and positive electrons is fed with oxygen, and electrodes are connected together through an external circuit. Okay. So in acidic fuel cell, the electrolytes is sulfuric acid, that means H2SO4, sulfuric acid, that means H2SO4. Okay. So at the anode terminal, that means negative electrodes, you may find out the chemical reaction. That means the hydrogen gas is ionized. That means hydrogen fuel. We just you may find out here. That means at the anode at this point. Okay, so hydrogen supply. So this will be at anode terminal. This hydrogen ionized. That means in H plus ion and electrons. Okay, so H plus ion makes the relation at this place in electrolytes, and electrons is just the electrons flow through this path to the cathode. Okay, so that things may be right in the chemical equation form. That means hydrogen H2 is ionized in H plus ion. Okay, so this 2H2, that means hydrogen is ionized, that is 4H plus and 4 electrons. Okay, so at the anode, we just to find the hydrogen gas is ionized and producing the free electrons. That electrons flow this one through the anode terminal to the cathode terminal. Okay, so that the electricity, or we can say that the current flow the opposite direction to this electron flow motion. Okay, that means from the cathode to anode, but the direction of electrons is flow from anode to cathode. Okay, so this is the chemical reaction at the anode terminal. Okay, so this H plus ion we find out here. Okay, next the cathode terminal. Okay, so just again in other types of explanation of the same things. So that means here fuel in, that means hydrogen. Okay, this H2 makes the free electrons ionized hydrogen, that means H plus ion, and these electrons are flow from this path to total movement here on the electrons, and through this path we supply the oxygen. Okay, so this oxygen, and make this oxygen and H plus ion. Okay, at the cathode terminal, that means make the water. So unused air and water, and heat goes outside from this path. Okay, so you have to concern about the chemical reaction at the anode terminal and at the cathode terminal. So you already find that at the anode terminals, 2H2 taking the hydrogen ion, that means 4H plus, and 4 electrons. So these electrons flow from this path, which is just already shown here by the direction. Okay, so from this path to this path, and through this one we just supply the air. Okay, so this oxygen make the chemical reaction with the H plus ion and produce the water. Okay, so that chemical reaction we can express here. That means every hydrogen molecules to, okay, brought to the electrode surface. Electrode surface is deassociated into two atoms by the virtue of catalytic property of the surface. Okay, what with A2. So at cathode terminal, the oxygen react with the coming electrons, and these coming electrons and hydrogen H plus ion from anode to give water molecule. Okay, just oxygen from this path, that means O2, and 4 electrons from this path anode to cathode, that means 4 electrons, and H plus ion, that is 4 H plus ion here in the electrolytes. So this makes the 2H2 water, two molecules of waters. Okay, 2H2, two molecules of water. So this is the chemical reaction at the cathode terminals. Okay, so you have to remember the chemical reaction at the anode terminal and cathode terminal. Okay, at the anode terminals and cathode terminals, you keep your chemical reaction in your mind. Okay. Next, I just want to do the same things, just how they can hydrogen molecules and electrons come at the flow of electrons here, and the red bubbles. Okay, that means hydrogen, and this one is a blue one, it indicate the oxygen. Okay, so from this path, hydrogen molecule put in these vessels, and okay, release some unused hydrogen from this path, and electrons, so that means flow from this to this, and the chemical reaction make, that means oxygen plus hydrogen plus ion and electrons, and so this is your path of water and some heat release. So this is all about, again, showing the some standard notation of the chemical reaction at the anode and cathode of the fuel cell. Next, alkaline cell. So in alkaline fuel cell, the electrolytes is potassium hydroxide, that is KOH, in place of H2SO4 here. So the important feature is that there is an excess of hydrogen oxide, that means OH minus ion, and these are play a key role in the reaction inside the cell. So in alkaline fuel cell, you will find out at the anode, hydrogen gas react with OH minus ion, producing the water and releasing electrons. So 2H2 and 4OH minus produce the 4H2O and 4 electrons ion electrons. Okay, at the anode, and just try to see at the cathode terminals. Okay, so that means 2H2 and 4OH minus make the relation of chemical reaction 4H2O and 4 electrons. So just we try to see here the chemical reaction at the cathode terminal, say in the alkaline fuel cell. Yeah. So things here showing in the systematic diagram is alkaline fuel cell. The basic difference between the alkaline fuel cell and sulfuric, acidic fuel cell is the electrolytes. That means where we use the sulfuric acid, but here the potassium hydroxide. That means KOH. Okay, in electrolytes. So main difference you can just find the electrolytes from the acidic fuel cell and alkaline fuel cell. Okay, so at the cathode terminals, the electrons and water at this point, that means at the cathode, from this path we just supply the oxygen and water. Okay, so water, that means 2H2O and 4 electrons from this side. Okay, so water and heat out from this path at the anode terminals. Okay, and this hydrogens makes the electrons, and this OH minus makes the hydrogen H2O and passes H2O from this path. Okay, so you have to answer. So O2 plus 2H2O plus 4 electrons, that means 4OH minus, the OH minus ion moves through the electrolytes and electrons move around the circuit. So the water product at the anode is used at cathode. Okay. And similarly, this is the chemical reaction of the fuel. That means the hydrogen and oxygen supplied to the fuel cell produce electrical energy, water and heat. So H2 and oxygen, H2 and release the heat. Okay. So here water and heat are wasted product. Okay. Water and heat are wasted product in the alkaline fuel cell. Okay. This is the next, last one is the basic difference you may find out between the battery and fuel cell. Okay, what is the difference between the battery and fuel cell? So the battery makes the electricity from the energy it has stored inside the battery, but the fuel cell makes it electricity from fuel in an external fuel tank. External fuel tank. Okay, that means you use hydrogen here as the fuel. Life time is less than fuel cell. Battery life is more compared to the fuel cell, and it stores the energy by the electricity. It stores energy by the converting available fuel. Okay. And battery run down the electrons dissolve, and fuel cell operates for as long as oxygen and hydrogen flow. And some other advantage you will find out here, that means this one, it has high efficiency and it has low efficiency. Chemical change are occurs. Okay. So this is all about it. So just we stop here, and in the next class we will discuss another things.